Good evening, ladies and gentlemen, and welcome to this presentation, the title, A Note on Sea Level Rise. And so I put these notes together because I have made some observations. I see a lot of assertions being made about sea level rise related to global warming, and there are some basic principles that I think would be helpful for people to understand before we make conclusions about sea levels rising and conclusions about what's happening to the world and to the planet Earth. I'm a civil engineer. I'm in Los Angeles, California. I was a professor for 10 years. I'm fairly well published in my field. I've done a lot of hydrology and hydraulic analysis. And I wanted to discuss just a few key points and share it with you to publish this in a paper form, which I have already written the article about, and share with you a couple of technical notes that setting all politics aside, I just want to approach this from an engineering standpoint and raise a couple points for you to consider. So let's first go over the basic premise of the global warming crisis as we view it. There are several points. The first point is that the temperature of the Earth is rising and causing a greenhouse effect, which is causing the Earth's temperature to rise due to the emission of carbon. That's the first assertion. And then by having a temperature rise, this is causing icebergs to melt and the Antarctica to lose its ice sheets, which further result in sea level rise. This is another major claim with the entire global warming premise. So I only want to talk about one topic. I want to talk about the issue of sea level rise, and particularly some of the mechanics involved and the physics involved in order for a sea level to rise. And number three is there's lots of anecdotal evidence that's been presented from around the world showing that certain islands are disappearing and that the sea level is rising and causing coastlines to disappear. I want to talk about that also. I'm not going to talk about the first topic, which is the most sensitive, which is the effect of the Earth's temperature and whether or not that's actually happening due to carbon emission, because I don't believe that I have really a justifiable conclusion on that, and I'm not going to make an assertion on that, even though the scientific community has some very heavy opinions on both sides of that. I will say this, that the Earth, the age of the Earth, which is agreed to by most Earth scientists, is approximately 4.5 billion years. We know that as a fact. Depending on who you talk to, this number will be somewhere between 4 and 5 billion. But I'm going to use 4.5 billion as sort of a median number there. And so here's my point on the temperature data. The temperature data that we have on the Earth's temperature, even if you take the maximum envelope of the scientists that they have gotten from ice cores from Antarctica, is on the order of about 400,000 years. Okay? I'm going to be generous, and I'm going to say make it 1 million years, which we don't have. It's about 400,000 years, but let's make it 1 million years. If you take 1 million years of data, which is pretty impressive, and you divide it by 4.5 billion, you are a very, very small percentage of the age of the Earth. And so my first contention is that the data sample that we have, because the cyclic nature of the planetary orbit with the weather changing from ice age to ice age, we've had thousands of ice ages. To make a conclusion on 400,000 years of data, at best, or make it 1 million years of data on what's happening with the planetary cycle, with a 4.5 billion year age of the Earth and the universe being on the age of about 15 billion years, 15 or 16 billion years, I think that there's a lot of issues there. Not trying to cast any doubt, but I think there's a lot of issues there on making a prediction over the span of the next 100 years when we don't really have sufficient data to be able to explain how the Earth has gotten to where it is on a 4.5 billion year cycle. So that's my first point. Second point is let's talk about the issue of sea level rise. And I want to go to a very basic principle of physics, which deals with floating objects in the ocean or floating objects in the sea. And let's talk about the iceberg. So when you take a glass of water, here's a little experiment, you can do it at home. Take a glass of water and take some ice cubes and put the ice cubes in the water, right? You can do it while we're talking. What's going to happen? So this is water, and this is the water plus the ice cubes. What happens? The level of the water will rise. No question about it. It will rise because by Archimedes' principle, and I'm not going to get into the math, although I'll be happy to, but today I just want to state the concept. The paper goes into the math. It's an accepted physics concept that the water is displaced by the volume equivalent to the weight of the mass, because there's a buoyancy force that pushes that object up. This happens when the density of the object is less than the density of the water. If the density of the object is greater than the density of the water, it will sink, but it will still displace the water. Now, if, using my rather simple example, you take that glass of water and now you let that ice melt, the level of the water remains unchanged. The water doesn't rise after the ice melts. It stays exactly where it is because the volume that was displaced when you put the ice into the water was already taken into account. Now, it sounds pretty simple. It's a very simple experiment. You can do it at home. And it is very simple. But let me show you why this is such an important point. Because we have an entire community of people, I'm not going to say who they are, some of them journalists. I haven't seen any scientists making this statement, but we have a whole community of people who are running around taking pictures of icebergs that are melting, saying that, oh, the ocean level is going to rise because the icebergs are melting. The icebergs do not have an impact on sea level rise. If all the icebergs were going to melt, it would not raise the sea level. I want to make that very, very clear. If we look at the Earth, we have two poles, the North Pole and the South Pole. We have a bunch of land, which are called continents. The continents are 30% of the surface area is land on the Earth. This is undisputed. This is not a number that I made up. This is established by fact. 70% of the surface area of the Earth is ocean. Let's go to the North Pole. The entire North Pole, which is an ice cap, has no land. It is all floating ice because there is no land at the North Pole. It's all ice. Greenland, which is up here, is a land continent. But the North Pole is an ice cap. The South Pole is a land continent which has ice on top of it. Okay? So let me make that distinction. Based upon this very simple example, if all of the ice at the North Pole were to melt, it would not raise the sea level. The ice at the South Pole is divided into two categories. There are the ice sheets. Okay, let me try to draw another diagram. So here's my ocean, here's my land, here's my ocean. I have an iceberg in the ocean. I have ice up on the land, which could be a glacier or it could be surface ice built over many, many centuries. The iceberg melting does not cause sea level rise. The only way the sea level rises is if the ice flows from the land into the ocean. That's the only way it's going to happen. Going back to the very simple example that I just stated, that the ice has to come from the land into the water in order to raise the sea level. Now that's a very, very important point because I see news reports all the time showing pictures of icebergs melting, the polar bears are running around. Okay, I understand. I'm not disputing. Remember, let's go back to the 3 points. I am not, in this little segment here, disputing or attempting to go into topic number 1. I'm not even discussing that. I'm only focusing on topic number 2, which is icebergs and sea level rise. And if all the icebergs were to melt, that would not result in any sea level rise. Here's another important point. Here's a little experiment. You can do this at home also. I know some of you still take a bath or go in a jacuzzi. Here's a jacuzzi or a bath. Here's the water. You get into the tub. What happens? You can do this all day. You get into the tub. What happens? The water rises. It rises by the volume of you being submerged into the tub. The more you go in, the higher the water level rises. Once you are submerged below your head, that's the maximum volume that you can displace. It doesn't matter when you swim around inside. It doesn't change it. But here's the point. When you get into the tub, the level that the water rises on this side is the same level that it rises on this side. It doesn't rise non-uniformly. It rises equally. What does that mean? It means that if we are having sea level rise, and sea level rise is occurring in Los Angeles, it will also occur in Hawaii and it will also occur in Tokyo. It cannot rise on an island in Fiji or on an island in the Bahamas or Tahiti. The sea level doesn't rise in Tahiti and then not rise in Los Angeles. It has to rise uniformly, and it would rise together. And so whenever I see news reports of people saying we're experiencing sea level rise over on this island, but there's no evidence over it in Santa Monica, this is completely wrong. It violates every basic principle of physics, and it's undocumented, and it makes no sense. So let's get a few points straight. We first of all have to agree that all of the icebergs, even if all of the icebergs melted, the only thing that's going to cause sea level rise is by ice flowing into the oceans. Now, what are the sources of that? I have a table for you. This has been established by NOAA. This is a listing. This table is an inventory of all of the world's ice, listed by volume. We have continental ice glaciers, we have the Greenland ice cap, boom, all the way down. This has been done by NOAA. This table is not generated by me. So the maximum percentage, let's take a look at this. The maximum percentage is coming in from Antarctica, which we already know, and Greenland. Everything else is very small percentages. This is your total world ice here at the bottom. So, look at this on the right-hand side of the table. This tells you whether it's in the ground, it's on the ground, or it's floating. The total Arctic Ocean pack ice is only less than 1%. Okay, so before we can have sea level rise, we have to first establish whether or not that ice can melt from Antarctica or from the glacial ice packs and then flow into the ocean. In order for that to happen, there has to be a significant change in the climatic cycle that would cause these ice caps to melt. And let me tell you, that would be a very significant global warming situation. And it's not going to happen right away. I have done calculations to calculate the time required in order to melt enough ice. I have calculated the volume of ice required in order to raise the sea level by 1 foot, which I will share with you in this Excel spreadsheet. I have done the calculations using 70% of the surface area of the Earth and calculated how much ice is required in order to raise the sea level by 1 foot. And let me tell you, it's a lot of ice. It's not going to come from icebergs, and you can't have Los Angeles not having sea level rise and Miami having sea level rise. This is utter nonsense. I see this on the news all the time, and it's utterly, utterly ridiculous. And those news reports have nothing to do with any science. And if they don't understand what happens to icebergs, we have to dismiss a lot of this information that's out there. But I wanted to present this to you just to get you thinking. I have written a paper on it. I will be publishing it. And the next video that I'm going to do is going to discuss the time requirement. What is the time requirement required in order to melt that ice? I'll just give you a little preview. In order for the ice to melt, let's look at the thermodynamic cycle. Okay? Let's look at a thermodynamic cycle, for example, Antarctica. And its thermodynamic cycle means here's my time and here's temperature. Time is going to go on a climatic scale, which is every 12 months. Okay? In Antarctica, you have a winter season, which is approximately 8 months. Frankly speaking, it's winter there all the time, but by definition, you have approximately a 3 to 4 month summer cycle, and you have an 8-month winter. If we use the zero axis to define 0 degrees C, and 0 degrees C is very important because 0 degrees C is the freezing temperature of water. And we graph on this chart, a very rough approximation of how that water temperature is varying in the Southern Sea, which is around Antarctica. The curve will look something like this. Not exactly, but close enough. And so you do have a period of time in there when you are approximately plus 2 degrees C above freezing in the Southern Ocean, which causes Antarctic icebergs to melt. And then you have 8 months of freezing. This has been going on for thousands of years. And during that 8, 9, 12, or 10 months of freezing, all of the ice that's on land continues to refreeze. And in order for that ice to thaw and then flow into the ocean, this curve has to change dramatically. It would have to become almost like you would have to almost lose your wintertime in Antarctica in order for that ice to thaw and flow into the ocean. So I want you to just think about that. We're going to talk about that in the next segment, but I hopefully have illustrated some basic points to you today to at least question. And again, I'm not making this video with any political affiliation. I want to make that very clear. No one's paid me to make this. This is strictly an engineer's observation. I'm not supported by any particular political entity or being funded by any agency. I'm only pointing out some basic fundamental points that I think that the world needs to be made aware of. Thank you so much.